Morning. How are you guys doing? And today we're going to talk about how to build agents a little bit secure, not a little bit, a lot secure at a high capacity. And when you build lots of agents, you need to make sure they are secure, they are on point, and you're able to do things that you don't want them to do. All right. Let's start with a quick question. How many of you have built an agent? Great. And how many of you has pasted a prompt in an agent and would have thought about it? It should not know about that, or why is it saying this to me? Right? So I've thought about all those things. So think about it. It's estimated to be 1.3 billion in 2028, which means you guys know when ChatGPT was released, May 2023. So in 5 years, we are going from zero to 1.3 billion. That's a huge amount, and everybody's building an agent at a scale of really high. And think about 1.3 billion people working across your data ecosystem. That's going to be really, really complicated, and it's going to be, it has to be super, super highly secure. So let's see, for 1.3 billion. So what does it mean? We have 1.3 billion agents. So what does it mean? We need to have a facilitate them to be discovered, managed. We need to figure out, how they are behaving appropriately or not. Are they sharing the sensitive information? It's not just sharing between the data and the agent. It's sharing between agent to agent, because with 1.3 billion, it's not a human in between every agent. There could be agent to agent communication happening too. And then we have to audit and govern them. So what does this mean in a security language? In a security language, that means there's going to be agent sprawl. 25% of the agents, people may not be using them. There are going to be data leaks because the agent, you have access to X amount of time. You forgot about the agent still have access to the data. Now you're oversharing your data. Now, the agent can also have multiple other agents depending on this agent, and how you're sharing is another piece to the puzzle. AI threats. This, a lot of people have done it already. It's called shadow AI, where you take your document, put it on an open LLM, ask questions. A lot of people do that today. But even though your organization doesn't want to do it, they do it, and it's called shadow AI. And that's going to happen a lot if it's not properly secured and cultivated enough. And then regulatory compliance. We're still figuring it out, and now we have to make sure we have certain guardrails, make sure they are all protected. It works fine, and then when it goes to the next level, as you know, ChatGPT the GPT models are doing in a different state. The next year they were like 3x better, and the next year they were 5x better. So just bubbling it out. Now we need to not set guardrails for today. We need to set guardrails for day after tomorrow, so we are protected along the way. And this is the whole threat landscape. I put it in this one slide, right? So from the top to bottom, we talked about sensitive information sharing. We talked about shadow IT. We talked about agent sprawl. It's just the use case level. The next level is the agentic application. I don't want to go through each one of the blocks just for the time, but I'm going to pick a couple of them to tell you what it actually means. At the bottom, you have prompt injection. Prompt injection is really simple thing where you can put in a prompt or manipulate it. I'll tell you an example. When the first versions of LLM came in, we were using prompts, and we put a guardrail around it saying, if somebody asks how to build a bomb, don't tell them how to build a bomb. And it was able to say, oh, I cannot tell you. But when those models started understanding images, I know people personally who have uploaded an image of a bomb and put a prompt in saying, tell me how to build what's in the picture, right? So that's manipulating ecosystem. Even though we put some guardrails searching for texts and pattern matching, there are other ways these hackers get really smart to do what they want to do. The next one is memory and context poisoning. This is a really, really big thing happening today. People send you a link saying, here's the link, click it, you'll get an agent. And the agent link URL will have some context poisoning, where when you ask about it, it gives you more information. You'll have no idea it knows, or it's giving an information based on the context. So those are the key things that's going on a lot. So they can ask about things, they can get personal information, they can do a lot of things on this space. The last two has to be a really text spacey, where you give the data set where it is more biased. you pick a group of folks, make the data set really biased, train the model with that biased data set. Now you have an LLM which everybody thinks is the right thing to do, but it's trained with a bad data set. The other one is called model theft, where somebody can take your IP trained model, reverse engineer it, and make the model reverse engineer itself, and then build a new model. So those are the levels we are going through. These are the full global threat landscape you have. And how does Microsoft handling this threat landscape is this slide about. These are all your common names you've gone through every day. You have a defender, which governs your phishing attacks, your make sure apps are good, and so on. Next, you have Purview, where you have kind of a governance layer. It's policy management. You have Entra, your user ID. You have Intune, where your PCs and devices are protected. So that's the regular names you have heard about. You have Sentinel, which brings them all together, and that has MCP server, embedded graph, and your data lake in the back. And we have Security Copilot, which is the agentic flow across these ecosystems. So you are not going to build each independent things in each one of it. You have a governing layer that goes across your ecosystem. That's how Microsoft is solving this problem we just talked about. So I just want to tell about the Security Copilot. So we went through an incident really in the recent past, where one of a live event happening in US was shared to an Asian country through a VPN in Europe. So it's leaving, and the person who hacked the stream, changed the voice to the local country language, and he published it to the local country. So that's the stretch it was happening. But with Security Copilot, we were able to find it, identify it, stop the stream, and we were able to investigate who the person is. And he's super smart because he did a lot of things, and that's what helped us go faster. So that's just a proof point of why we are talking about it. You have the secure layer, where you have the investigation and remediation. You can reverse engineer any injection of scripts. You can do the risk exploration and posture management, and you have troubleshooting. And final one is the policy control we talked about. Okay, this is the full set of all the agents we look at. You have the first party Microsoft agents, and you can build third party agents and connectors that can flow still into Security Copilot portals. And you have custom built agents that you're going to build by yourself, which you're going to take a look in the next screen, and how we can all come together at Security Copilot. So before we jump into building your own agents, let's talk about the agentic complexity curve. So I put in 3 levels. The first one is smart assistance, whereas you build a task, you ask a question, it replies you back. So it's not heavy complication to go. This is what a lot of people are doing it. 50% of the folks are doing this today. So it's just a single NLP layer, low code, no code, one model, and you get a Copilot add to it. So that's what a lot of people do. The next level is a little complicated, where you have multiple agents talking among themselves. You can orchestrate them for each task, tuck them together. There's runtime reasoning happening, where it figures out, oh, you're not saying the right thing. Now go back and find your data again, kind of that layer. The last one is the adaptive platform, where this is all the OpenClaw and all the things that's coming up, you're hearing up, falls in this layer, where each agent learns a skill, and from the skill it builds a code, and it evaluates the code, understands what's wrong, and go back and rebuilds the code. So that's the top layer. So this is the complexity curve. Across these curves, you want to build an agent. Microsoft have different platforms for you to go through that to build an agent. The leftmost one being the task-driven. You have Copilot, you have workflow stitching, and you actually have the Foundry one at the end, where you can write with custom models. So let's go back to the basics. How do we understand? So I want to make sure everybody understands that agent and apps are not the same. Apps, you define it what to do, you give them a perfect set of instructions, it goes through the flow. Agents has its own intelligence, it's going to make decision on your behalf, and it's going to make things that you did not, or you expect it to do, or tell it it's like a teenager. Sometimes it does, sometimes it doesn't. So we need to identify, track, and do a bunch of things on what it is doing. Suppose, let's say you make the agent build a beautiful picture, showcase it. Who owns the picture? Do you own the picture, or does the agent own the picture? We don't know, right? Because you are the intent of doing the picture, but you did not do the picture. So there should be a way to preserve this ecosystem for downstream information. So that's the agent ID. We give an agent ID to each agent. It's part of your Entra. Again, nothing is brand new. We just added things on top as a protection layer, and it's a new technology coming in called agent ID. It's very similar to user ID, but it has different profiles. It doesn't have passwords, it has key-based authentication and kind of all those things, goodness to it. So once you have an agent ID, when you build your agents across Microsoft or a third-party ecosystem, you get your protection, your network security, governance, authorization, authentication, kind of the whole loop in here. So next, I want to just go through a simple workflow. Now, let's say I want to build an agent. Everybody says, I want to build an agent. I have an app that's working. I want to build an agent on top of it, give access to people who can access my app. Today, it's all over the place. People, some of them doing it right, some of them moving their authentication all over the place. So we want to make sure everybody understands how the flow is. It's a simple flow. It's a media flow. You have a visual effects coordinator who works on a show. He has access to the visual effects data. You have a costume designer who have access to another show's costume design data, and you have a producer who needs access to both the data. So that's the workflow, which everybody has seen it. So again, Ryan can access only VFX. Sophia can access only Crown and Chaos, and Jordan can access both sides. Let's see. It's a demo video where we showcase how you log in. And again, this is the VFX coordinator logging in. The visual effects coordinator obviously has to use username, password, and definitely should use an MFA. So you can see even with the demos, we go through that process. Once he logs in, he's asking questions about the show he has access to. He's asking about the shooting, so he can adjust the visual effects joints. So he gets the right answers. This is what he should have access to. This is the right thing, and it's a valid query. Now, when he starts asking about costumes, the agent goes back and says, oh, you should not be asking about the costumes, and puts the access to it. Now, the agent should not be making this decision. This decision should be outside the agent, because the agent, has intelligence. Agent can also hack something, so you got to be careful about that. Next, the costume designer logs in. He puts in his, MFA, and you can see he has logged in on the top. He asked the questions about costumes. It comes back with a valid answer. When he asks about visual effects, and this one is more critical because he's asking about visual effects and budget, then the agent says you're not allowed to access that. Again, this is coming from the data layer, which everybody have already authorized the agent or your application to talk to. The agent is just in the middle, figuring it out who is asking and does he has the right access or not. So that's what the agent is doing. So this is the final one where the producer now logs in. The producer puts all the information again. He puts in password. It goes through MFA. Why I'm showing these steps is just to showcase that it's a regular thing you do every day, and it has to go through the same process. Because of the agent, it shouldn't be easy or it should be hard. It's the exact same thing. So now he asks questions about both visual effects costume. You get a bunch of details. He's asking about the show and the budget, and he gets full access to the ecosystem he plays. This is exact app you do today, and we just added an agent in the front. So as you can see, this is what I've been explaining to you. The show user first goes through the web front, which everybody has. You embed in the web front. The web front asks the data agent saying, hey, I would like to access this. Now the data agent is just in the middle, and your authorization is all in your data layer. Now the data agent asks on behalf of the user. So the data agent is not doing it, but it's also doing it on behalf of somebody. So you approve the agent to go do the job. The agent does the job. It does not retain the information. It gives back to the user. So that's the whole circle that we've talked about. So if you want to build a new agent, just follow the process. If you already have an app that's working and you want to add AI in front of your app, use this process instead of embedding the agent as part of a user token. So this way, the agent does not have access that you don't have, and it only works on your behalf. So final one, we talked about observability. I'm going to run the video on the observability side.
Becoming part of everyday work, helping teams move faster, automate tasks, and scale ideas. The big question is, how do you keep it all secure, compliant, and under control? The good news is, you don't need to start from scratch. Give agents the same tools as your users. Extend your existing infrastructure, apps, and protections to agents. leveraging familiar capabilities tailored to their needs. With Microsoft Agent 365, every agent is registered, visible, and governed, all in one place. The result? Strong security, enhanced confidence, and a simpler path to scalable AI.
So what does Agent 365 do? It does the observability we talked about before. It does role specific oversights. It does the whole observability ecosystem is covered. You have governance and you have a security layer on top of it. So those are the three major things we talked about. It's all covered under Agent 365. And this is a quick screen view of how your Agent 65 will look like. The Agent 65 is embedded as an agent inventory, and then you have an active user coming back in. And then it showcases the whole ecosystem in one panel, so it's easy for you to overview it. It has APIs too, so you can interact remotely to make your everyday work. And Agent 365 is not just for Microsoft ecosystem. You can build agents on other ecosystems. Still, it becomes part of Agent 365 when you use the right SDK and layers on. And yeah, that's my last slide. Sorry, Jim. Thank you, Jim. So yeah, any questions, let me know. I'm here and we can talk about it.